R is an object-oriented programming language, and everything is really objects in R. But a lot of the time you're storing data in the objects, and to do that you need to understand the different data structures R is capable of using. And I'll go through them here. And the first one, the simplest one, is the vector. The vector is just a row of values. It's a one-dimensional, that is, it's just values after each other. It could be numbers, or it could be letters, or true, false values in a logical vector, but you can't mix data types in a vector. You can only have one type of data. You can't mix digits and text, for example, but you have to stick to one kind. The matrix is a two-dimensional version of the vector, so to say, and there you have columns and rows, and you can store only one data type at a time. And the array is when you have even more dimensions. You have three-dimensional or four-dimensional objects with the same type of data stored in several dimensions. And we'll get back to this. A factor works quite like a vector, but it's not a vector. And the difference between a factor and vector is that the factor contains data which has only pre-specified levels. So, for example, a vector could contain ages or some sort of measured value, but the factor contains something that can only have a specific number of levels. For example, gender, which could be male or female, but not anything. Or it could be grades in a class where you could have A, B, C, D, or F, for example, but nothing else. Time series is a 1 to 2 dimensional data structure, which we will not go into any further. It might be useful to some of you, but we have not been able to use it very much in our research because it has limitations that are troublesome to us. So we won't go into that any further. A data frame is sort of like a matrix. It has two dimensions. It has columns and rows, but unlike the matrix, you can actually store different data types in the same data frame. So this is the one that looks the most like, for example, a spreadsheet in Excel. But there is a limitation to these data frames, and you can only use one or store one type of data in each column. So each column has to contain, for example, numeric values or alphanumeric values or logical values, and you can't mix them. But you can have different columns with different values in them. And the list, lastly, that's a rather complicated data structure where you can store objects within objects, and the objects can be of different length. So you can use this to store almost anything. And the problem with lists is that they are rather difficult to subscript, but you still have to use them. I try to use them as little as possible, but a lot of the output from commands in R is in the form of lists, and then you have to deal with them anyway. So we'll look at lists as well. And for those of you who are more graphical minded, this is an attempt to show the same thing, but graphically. We have the vector here with a row of values, in this case a numeric vector, and here we have a character vector with letters in it, and you can't mix them. The factor looks quite the same, but the idea here is that, for example, in this case, you could only have ones in series. You can't have twos in this factor because they could, for example, mean that the patient has died or the patient has not died, and you can't have any other values, and then a factor might be the best thing to use, and it guides the way R uses these values when performing different commands. The matrix is a two-dimensional structure with, in this case, numeric values, and this another mode, character mode. Here's the data frame, and as you can see here, I've entered column names. You can have column names in the other ones as well, but it's very useful to have them in the data frame for subscripting. And as you can see, you have numeric values in these two columns and something else in this column that's allowed in a data frame. The array, in the picture here, we show a 3-dimensional structure because it's rather difficult to show 4-dimensional structures, but you can have as many dimensions as you wish in an array. The time series we won't go into, and the list doesn't look quite like this. And this is not a good interpretation of the list, but I just try to show that it's rather complicated the way the list works, and we'll definitely get back to that.